Hi, algebra students. Today we're taking a look at some more piecewise functions. So first we have a whole bunch of equations here that we're going to graph as one function. We have 1/2 x squared from 0 to 12, 72 from 12 to 28, negative 9x plus 324 from 28 to 32, 36 from 32 to 44, and last x squared minus 100x plus 2500 from 44 to 50. And that's all going to be graphed on this one coordinate plane where the x-axis represents distance and the y represents speed. So in the end, we're going to come up with a scenario that these lines create. So first, let's set up our x and y axes based on the scales given. So distance is in multiples of 2, so I'm going to label every other by 4. So it makes that last line 50. And then speed is in multiples of 6, so I'm going to do every other by 12. So that gets up to 96. Then I'm going to go over to my calculator and enter in all of those lines. So we have 1/2 x squared, which is quadratic because of the x squared term, 72, which is going to be a horizontal line at y equals 72, and then negative 9x plus 324, which is linear because it's in y equals mx plus b form, 36, which will be a horizontal line at 36, and x squared minus 100x plus 2500, which is again a quadratic function. We pull up the tables and we can see all the lines we have to graph. I'm going to start at 0, so I'm starting at the right point. So our first one, we're going to start with the column in blue from 0 to 12. Remember that if you have a less than or equal to sign, that's going to be a closed circle, where if it's just less than, we put an open circle. So for the first part, from 0 to 12, we have 0, 0. Skipping to 2, we have 2, 2. Then we have 4, which is 4, 8. Then we have 6 at 18. Then we have 8 at 32. 10 at 50. And 12 at 72. And that's where we put our open circle, since in this case, we are not including that point in this equation. Then we draw our partial quadratic curve. All right, then we have 72, and that's from 12 to 28. So as you can see by the red column, we're going to stay at 72 all the way until we get to point 28. So we just have a horizontal line from 12. So I'm going to close that circle all the way to 28. There. And I have an open circle there to start because, again, this is less than or equal to, and this is less than. Okay, then we have negative 9x plus 324, which is my column in black. So you see I'm at 72 again at 28. So I can close my circle, and I'm going to follow that until I get to 32. So 28 stays at 72, 29 is at 63, 30 is at 54, which would be halfway between 48 and 60. 32 is at 36 with an open circle, and I have my linear function there. And then I go to 36, which is my column in magenta, and that's going to stay at 36 until I get to 44. So a straight line staying at 36 and closing that circle until we get to 44. And then we put another open circle there. And then we jump over to the last column in green. I have to scroll down first so we can see it. We want to get to 50 and then go over to my green column. So at 44, I'm still at 36, so I can close my circle. Then 46 goes down to 16. 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 which is about here. And 48 is at 4, which is about here. And 49 is at 1, 50 is at 0. So I can finish my curve there. And in both cases, my dots are both solid here, equals and equals. All right, so there I have my piecewise function that we can now create a scenario around. So we could say, Mrs. Kiesler drove to the grocery store. For the first 12 miles, she accelerated until reaching 72 miles per hour. Then she stayed at 72 miles per hour for 12 to 28 would be 16 miles. Then she decreased her speed to 36 over the next, why I turned to black, I'm not sure. 28 to 32 is 4 miles. She stayed at 36 miles per hour for 32 to 44 is 8 miles. Then decreased her speed and came to a stop after how many more miles? So 44 to 48, 4 more miles. So you get the point there. It should be 4 more miles there. Hopefully you can fit it in the space that I gave you. All right. So it's pretty simple. You should be able to do this without too much challenge here. So you're going to try the next problem on your own.